So, hello everyone, good morning. Today we will try to conclude DMRS. Okay, and I had some set of questions that I want to answer. We will look at multi-port transmission and some more examples so that it becomes clear. Okay, so we'll try to conclude DMRS today so that next class onwards I can talk about CSIRS and SRS. Okay, which are a little bit different from this. We will take time to do those things again. I think today there is some holiday. I don't know what it is. I think that's why people are not there. So anyway, it's a short. We will try to finish up wrap up DMRS. So it's okay. Next class I'll start next topic. Am I audible?
Yes, sir. You are audible, sir.
Okay. Okay. Fine. Good. So let us continue our thing, and then we'll take up the questions. So yesterday, what did we look at? We looked at both time allocation and the frequency allocation. Okay, and we also saw how this WF of K dash and WT of L dash gives you a code. So today, let's look at some examples, and we'll come back to this slide later. Okay. So this is a very straightforward example. I'll also look at some examples from a website called ShareNote. Lots of examples there. So I will open up that website and we will discuss those things also. Okay. So this is a single port transmission. So single port transmission, so I said P equal to 1000, delta equal to 0, L0 equal to, L bar equal to 10, so on and other things. So you see that you see every alternative. So it's a type 1, type A PDSCH mapping and type 1 DMRS. So you see it's on the 0, 1 second. Every alternative symbol is a DMRS symbol. Every alternative RE is a DMRS RE. So it's a very straightforward map. Suppose now there are two ports. Okay. So in the same example, we want to transmit two ports, 1000 and 1001. So what will happen? You look at this 8. So this and this will be the same. This will be plus and plus, plus and minus, plus and plus, plus and minus, so on and so forth. Okay. So you see that both these things are actually overlapping in the time and frequency. Okay. Both port 1000 and port 1001 are overlapping. Yes. You separate them out using the CDM code division multiplexing that we have learned in the MIMO wave channel estimation. Any clarifications on this, please? Any doubts on this? Okay. So I give an example here on how you separate out this with code multiplexing. Anyway, this is something that we have seen, so I'm not going to spend time. The only assumption that you make is that the channel is constant across these two pilots. So this is one port, this is the second port. For these two ports, the channel is constant. Similarly, for these two ports, the channel is constant. Okay. When you make that assumption, you'll be able to immediately find out channel H1 and H2 based on the orthogonality of P1, P2. These two. Any question? Okay, so suppose there are 4 ports. Okay, there are 4 ports now. CDM, I hope you can see this. Let me see if I can move it in the presentation more so better. You can see this now, 4 ports. So this is CDM group 0, this is CDM group 1. Okay, so in this one and this one are overlapping. This one and this one are overlapping, but this is minus. All the blues are minus and the yellows are plus. Okay, so this and this. So you can see this forms one CDM group. Okay, so these 2 ports are fine. What about these 2 ports? You see this one and this one separated out in frequency. Okay, so you see this is in RE5, whereas RE5 is there's no pilot here. Okay, so this and this are separated in frequency. So there's an FDM here, frequency division multiplexing in terms of pilots. Okay, this and this are overlapping. This and this are CDM group 1. Both the things are overlapping and they are separated. They can be separated out by the code division multiplexing. Is this clear? Any question?
Excuse me, sir.
Vijay, this is Vijay.
Here, sir, if you take 1,000, so 1,000, normally the white cells are the data cells, no, sir. Data
Yes.
are resource elements.
Yes, yes.
So normally the pilots we send to estimate the channel so that this data can be recovered. But if you combine CDM group 0 and group 1, no data will be sent, no, sir, in the
Yeah, exactly. Yeah, that's a very good question. So this is the question you asked me also in the thing. So what happens is when you're sending this one, for example, this port 1000, this is 1000 port, 1001, 1002, 1003. If you look at port 1000 and port 1002, okay, so this layer 1, layer 2, layer 3, layer 4, okay. So port 1002 and port 1000, what you say is, let's look at this thing. At this point, you're transmitting a pilot and this data here, okay. So if you transmit data in this particular point, in this particular RE, what will happen? This data will collide with, interfere with the pilot, okay, and this pilot will become useless. And similarly, the data cannot also be decoded because you're sending some pilot here. So what generally happens is, for 1000, when you're transmitting this CDM group 0 and CDM group 1, you don't send any data here. You don't send any data here. Similarly, you don't send any data in this point also. You don't send data here in this point, and you don't send data in this point. So when I say in this point, it means also in this point. Okay. So whenever pilots are overlapping with data, the data will not be sent there, because so that there is no interference between the data and the pilots. Vijay, that answers your question. I'll go into more depth in that thing. I'll tell you how the UV will understand whether there's data there or no data there, other things. I'll tell you in a couple of slides.
Okay, yes.
But is this clear?
Yes, sir,
so
it is.
As you said, when we are transmitting CDM group 0 and CDM group 1, for example, more than 2 ports, here 3 ports or 4 ports, what will happen is there will be no data in the symbol, and the symbol 2, 0, 1, 2. In the symbol 2, there will be no data at all for that particular UV. For that particular UV or a group of UVs. Okay?
Sir,
Yes,
in that case, the entire symbol is kind of pilots only.
Pilots. But I mean, the pilots are interleaved in FDM manner. Okay, see, this is for that particular UV. There may be some other, like after 50 resource elements, there may be another UV in which you are sending only 4000. Okay? Or for that particular UV, there will be no data in that symbol.
Okay. So the other symbols, it can be used for data.
Other symbols you can use it for data. I mean, there will be other pilots and other things also, but that's it. I mean, that's out of, I mean, effectively you can use them as and how you want. Any other question? Okay. So this is a type 2, sorry. So this is type 2 DMRS, in which we have seen this. We have seen this example of type 2. No? I mean, the density is 1/3. The density is 1/3. Every 6 symbols has 2. So the density is 1/3. It's very straightforward. This is single port, dual symbol DMRS, double symbol DMRS. Okay, still type 1. Okay, so you see the example here. I mean, you can go through these examples and carefully and put those numbers and other things and understand this, but very straightforward example. Okay. So this is a summary of this is for the type 1 DMRS. So you see the type 1 DMRS, single symbol DMRS has 4 ports. Okay. So you see that the first two ports are CDM, and the second 2 ports are also CDM, and the first 2 and the second 2 are separated out in frequency by 1 RE. Okay. Similarly, for the double symbol DMRS, there are 1, 2, 3, 4 different CDM groups. Okay, because you can have more number of ports. Okay, and they are also separated out. Some of them are separated in frequency, and some of them are separated in code. Okay, the CDM group 0 is separated in code. Similarly, group 1 is separated in code. Groups 1 and group 0 are separated out in frequency. So this is for type 2 DMRS. Okay, type 2 DMRS also the same thing happens. Okay. So the basic thing is the default DMRS type. So what did we see? We saw that this particular IE is required. Now, what is it called? DMRS config IE is what configures the entire DMRS. This particular thing, DMRS downlink config. Okay. But this thing, this DMRS downlink config IE comes only after everything is attached, all RRC parameters are done and everything is done. Only once everything, the patch, everything is completed, this DMRS downlink config IE is sent by the base station. Before that, what happens? What is the default thing? The default thing is always type 1 plus single symbol DMRS. Okay. So for any transmission that is scheduled by DCI 10, okay. So for now, what you can think about DCI 10 is the basic downlink control configuration. Okay, it's the basic it's called the basic configuration for downlink control. Okay, so anything that is scheduled by DCI 10 will use the default DMRS, which is configuration type 1 plus single symbol. Okay. For example, paging and system information, all these things used the basic default DMRS. Okay. So all the things before the UE is provided with the PDSCH config. PDSCH config has this DMRS config. I mean, in the one of those IEs. Okay. The default DMRS is used. Okay, remember this. So this is where Vijay, I'm going to explain a little bit more about this. So this is called the DMRS and PDSCH multiplexing. Okay, so this is what we saw. For port 1000 and port 1001, when you're transmitting single port, there's no issue at all. When you're transmitting 2 ports, the CDM group, there's no issue. That in this empty things, you can actually send PDSCH. Okay, let me just make it full screen. In this empty things, you can actually send PDSCH data. Okay. But when you're sending more than 2 ports, for example, 3 ports or 4 ports, what happens in these data? I mean, these empty things are overlapping with these pilots in the other ports. So if you send any data here, what will happen? That will start interfering with these pilots. So what you do is you don't transmit any data here. Okay, you don't transmit any data here. Similarly, you don't transmit data here. Similarly, you don't transmit data here. Okay. So that the pilots are clean. Okay, so when you say you don't transmit anything here, essentially you're effectively transmitting 0 or nothing. I mean 0, effectively you're transmitting 0 in that particular RE. Right? So sometimes DMRS and PDSCH are multiplexed when there are a small number of ports. Sometimes you will not be able to multiplex DMRS and PDSCH. Okay, so it depends on what is the particular config that particular number of layers that you have and other details. So the question is, how does the UV know whether the DMRS and PDSCH are multiplexed? How many layers it is sent? Okay. So this is what I'm going to tell you how this is done in the next couple of slides. This one, right? So this problem occurs only in DCI format 1.1 because DCI format 1.0 is only used, no MIMO is not supported in DCI format 1.0, and therefore it only uses single symbol DMRS. Single symbol DMRS, there's no issue at all. Okay. So the only problem happens when MIMO is used because multiple ports come in MIMO, and in that case DCI format 1.1 is used. So the question is, how do you decide whether PDSCH and DMRS are multiplexed or not? Okay, so that is what we are going to look at now. So this particular thing, DCI format details are given in 38.212. So in 38.212, some tables are given. We'll look at those tables now. Okay, and that will explain us how this is done. So essentially, effectively, the question boils down to, so if the UV knows how many ports are used, then there's no issue at all. Okay, you can figure out that this is a particular thing that is used. So therefore, there is no PDSCH that's multiplexed with that or not. Okay. So, but how does it know? So let me open up the. So we'll get into the DCI formats in great detail. For now, the number of antenna ports are determined by some number of bits. Okay, 4 or 5 or 6 bits. Okay. So depending upon the DMRS type and the maximum length. Remember, the maximum length means essentially the choice between single symbol and the double symbol DMRS. Okay, we learned this yesterday. You have to look at a particular table. Okay, and each of the row of the table is given by the bits in the DCI. So 4 bits correspond to the 16 rows of this table. 5 bits correspond to the 2 power 5, 32 bits, 32 rows in this table, and so on and so forth. Okay? So I'll show you the tables, how the tables are. So this is one table, second table, third table, and this is a bigger table, fourth table. Okay? So what do these tables have? Let's just look at one table. So essentially what I said, the DCI will tell you the row number. Okay. So the DCI will tell you the row number, and once you tell the row number, the UE will know which port is being assigned to it. Okay, which port is assigned to it. Okay, because you have to think about the one thing. The same thing holds true for multi-user MIMO also. Single user MIMO is one thing, multi-user MIMO is one thing. Okay. So for example, you are doing a single user MIMO and you are transmitting only one layer. Then for example, with this particular DMRS type equal to 1 and max length equal to 1, that means single symbol DMRS. Okay. So if you send 0, the number of ports automatically becomes 0. Okay. So essentially this means that the UE will know that only one port or one layer transmission happened. Okay. So it knows that in this particular case, the data can be multiplexed with DMRs. Okay. So you can transmit 0 or 1. Why there are 0 or 1? Because you can have 2 users. Fine. If there are 3 users, then you can transmit 4, 5, and 6, and so on and so forth. Okay. So when you transmit 0, 1, that is fine. So suppose you transmit 2. Okay. So what does this mean? It means it's 2 layers. The number of ports are 2 layers, but it's only one CDM group. Okay, so that even now the DMRS can be multiplexed. Okay, DMRS and data can be multiplexed. Now let's come into the other case. When there are 2 CDM groups used. When the 2 CDM groups used, and depending upon the particular configuration you have, okay, you know that the data cannot be multiplexed with the DMRS. So the UVs will know exactly that, okay, 2 layers have been, two CDM groups have been used. So there's no data between the DMRs. Is that fine?
So here value 3, example, so value 3, number 2 is then CDM group 2.
CDM
So
group 2.
Here we should take, for each group, we should take 1 port, sir, for each group.
In this case, only 1 port transmission for that particular UV. So you think of the multi-user MIMO in this particular case.
Okay.
Okay. So with 2 CDM groups, you can transmit 4 users now.
Yes, sir.
I'm sending single layer to each user. Okay. I'm sending single layer to each user, but the pilots across the users are interfering with, will interfere with the data. Yes. So when you put the CDM group 2, there are 2 CDM groups. Okay. So let's just go back to this, my slide once. I'll show you this. Okay. So now let us look at multi-user MIMO. So in this case, what happens? I'm sending multi-user MIMO. I'm transmitting single layer to each user, but I'm serving 4 users. Vijay, is this clear? Is the setup clear? 4 users. I'm transmitting only single layer to each user. Okay. So then what will happen? What will I do? In this table, for first user, I will send a value. I will send a value 3. For the second user, I'll send a value 4. For the third user, I'll send a value 5, and the fourth user, I'll send a value 6. So what will happen? The first user will know that he is transmitted on 1000th port, second user on 1001, 1002, and 1003 port. Okay. So when I'm transmitting these things, even though I'm sending single layer to each user, I cannot transmit any data in this because this third and fourth users pilots will interfere with my data. You understood? So in this particular case, each user will, so for example, the user 3, the first user will look at the value 3. It knows that it is transmitted on a single layer, but it knows that CDM group 2 is used. So immediately it will understand that, okay, the CDM group 2 is used, means both the CDM groups are used. Hence, there will be no data present here. It will be empty. Is this clear, Vijay?
Yes, sir, clear. Sir.
Okay. Okay, so this is for 4 ports. If you want more number of ports, then you have to use max length equal to 2. So if there are bigger tables, I mean, larger number of tables, you can see the same, what do you say, same logic holds true. Okay, the more number of tables. Okay, so that is how a user understands how many layers have been transmitted to that particular, that particular user. Based on that, it will know how many CDM groups, either both the CDM groups and the number of layers it got for the particular user. Okay, so in this, for example, if we send 7 for one user, what does it mean? It means 2 CDM groups are used and 2 layers are associated for that particular user. Fine. Suppose it sends 10. What it means, it's all the 4 layers are assigned to that particular user with CDM group 2. Did you understand? Is this clear? Okay.
Sir, then it is kind of single user MIMO.
Which,
All layers are.
all layers are sent to that particular user. It's a single layer MIMO. Okay. So you can use the same table for multi-user MIMO as well as single layer MIMO. Okay. Suppose you are using multi-user MIMO with the 2 users. Suppose you are using 2 users. You are doing multi-user MIMO and you are sending 2 layers. Okay. There are multiple ways of doing. You can send 7 to one user and 8 to one user. Yes. Or you can send 7 and 11. Not 7 and 11. 8 and no. You can send only 7 and 8. Those are only 2 options possible.
Yes, and we can send 3, 4, 5, 6 also for 4 users.
3, 4, 5, 6. You can, for each user send, you can only send 1. Nah? So if you send 3, 4, 5, 6, each user will get only 1 layer.
Yes.
Okay. So you can send 3 layers, for example, by using this 9. 0, 1, 2 is 0 to 2 is 1. 9. So okay.
Okay.
Good. So similarly, you can look at the other tables. There are more number of layers. I mean, you go down, you can see much more number of layers possible. Okay. 3, 4, 5, 6, 7. DMRS code 0, 1, 2, 3, 8, 9. So all the 8 layers are possible. Okay, so we'll also, I mean, so you have to choose the correct table based on the DMRS type and the maximum. Again, these are indicated in the, what do you say, in the DCA formats. Okay, DCA formats and some, we'll come to that later when we do the DCA formats. Any other question? Okay, so this is what I explained. Okay, good. So with this, we conclude our DMRS thing. So I want to take some time and answer some of the questions that I think this Vijay sent me some set of questions. I don't know what this is. Let's look at this. Vijay, can you is the same question that I answered now?
Yes, sir, but everything is clear except the last question, sir. You can go to last questions.
Which is the last question?
Yeah, yes. Yes.
Tell me. The reason for symbol 2 and 3 in the downlink is to locate the first DMRS location of the corset. Yeah, that's true. When you're having mapping type A, most probably the corset, I mean, the typical location of the corset is the first 2 symbols. Okay, that's why you have it in symbol 2 or symbol 3. Because your corset can be either 2 symbols or 3 symbols. Vijay, that's correct. Absolutely correct.
So it assumed that then corset will start from the symbol slot.
Symbol 0.
Symbol in the slot, sir. First
symbol 0.
Okay. Okay.
So symbol 0, symbol 1. Then you can put your DMR as a 2. If your corset is 3, corset is length of 3, which is the maximum, 0, 1, 2, then you can put your DMRS in the 3rd location.
Okay, sir. Then it's sufficient.
Yeah. Okay. So what I would suggest is, I would suggest everyone to look at 38211. Where is 38211? I would suggest everyone to once go through this particular document. Okay, so this particular document 7.4.1.1 demodulation reference signals for PDSC. I would suggest you to read this once. Try to understand, and it's actually pretty small. There's a couple of pages only, but I want you to understand this once. Once you start reading the spec, it becomes. You will see that there's a lot of jargon, but it will take you about half an hour to 1 hour to sit down, put everything together. There are some exceptions for DMRS, for example. Okay, so I would suggest you to go through this particular thing. Okay, so these exceptions and other things I did not go through this in this class because that's something that you have to read. There's nothing more to it. Okay, so please, I suggest everyone to read this. And if you read this carefully, one thing that we can do is we can write our own code to generate the DMRS. That's actually a very, very good way of understanding the spec. Okay. See, until now, what we were doing, we were just generating OFDM signals, and you have also done an assignment on LDPC and rate matching and other things. There we were using the functions that are given by MATLAB. Okay. So generally, what I do in my classes, I make all the students write the way, the technique to generate DMRS. DMRS for PDSC. Okay. It kind of makes you understand the spec and gives you confidence that okay, it's just a question of reading it. Okay, so I would suggest you to actually read up to this point. Which is the end of DMRS. You might have to read 38.331 and other things based on the IEs and 38.212 based on some of these things, some small parts of this. You read this, and then I want you to ask me questions. And then we will see if I can simplify the implementation of this, and you can write a small modules in MATLAB which can generate this DMRS. Okay, I will help you out. I will do most of the things in that, and you might have to fill in the blanks up. You can write some small parts of the code. Okay, that will tell you once you write the DMRS, you'll be able to generate anything, any other pilots in. It's very straightforward. Other pilots also are very, very, very similar. Once you write this, you will be able to generate for any other pilots also the corresponding values and other things. Is this fine? We'll take it slowly, that MATLAB part. But for now, what I would suggest you to do is in the next, by the time we meet on Saturday, I want you to go through this, please. Okay, everyone. Okay, this is something you have to understand. How do you generate this C? You have to think about this once. Okay, go to C. That's there in the generic functions file. The section 5, you will have the thing about the sequence generation. 5.2 will have how to generate the C. I want you to look at that, think about it once. Okay, think about it, take a pen and a paper, okay, and see what all you require to generate this C. Okay, and then start reading up all this. It's 3 pages, and there are lots of tables, so it's effectively 2 pages. So please read that, and then we will have a 10-minute question answer session in Saturday before I start CSIRS. Once you understand this, CSIRS and other things are become very, very, very straightforward. Okay. So I want you to read this, and of course, in the textbooks that I have put there, I would suggest you to read those DMRS for PDSC chapter also. Once go through that, okay, it will give you more pictures on this DMRS and other things. So one thing that I told I will do is share note. Share note. Let's look at it. Okay, here they give lots of examples. Okay, I'm going to just zoom it 1 minute. All of you can see the screen. Okay, so let's just go through a few examples and then we'll stop today. And next class I'll start CSIRS. Okay, so again, this is simple, straightforward. It's mapping type A. So what is mapping type A? Can anyone tell me? Mapping type A means what?
It starts, if it is a type A, sir, it starts with second or third symbol.
Yeah, that's what type A means. Essentially, everything is measured with respect to the 0th symbol of this block. Okay, what you said is absolutely true. It starts, the DMRS is either in the 2 or the 3rd location. Okay, this DMRS config type 1. Type 1 means essentially density is half density. Okay, additional length is equal to 1 means it's a single symbol DMRS. Okay. Type A position. Okay, number of CDM groups without data is equal to 1. So this is the index in the table. Okay, so you see that it's nice. So now we have 2 layers. So these two layers, port 1000 and port 1001, everything is the same. So are separated in the CDM group. Okay, this and this, these two things will be separated in CDM group. Okay. Now you have 3 layers. So when you have 3 layers, what happens? So they put these blue things. Huh? So earlier these things were green. The data can be used. This thing, the data can be multiplexed here. Okay. But when you have 3 layers, you cannot use these things for data. Is this clear? Because this yellow thing will overlap with this. So there is no data here. So you put zeros there. Is that fine? Similarly for 4 ports. 4 ports you have, I mean, this is one CDM group, this is the second CDM group, and because they, I mean, you see that all the intermediate positions are all zeros. Okay. I think this is for multi-user MIMO, because see, the number of CDM groups without data is equal to 2 its put, so once you put them, automatically this becomes green. Okay, we'll see some other complicated examples. Same thing. This is configuration type 2. So you have two pilots for every 6 RX. Okay. With configuration type 2, with number of CDM groups without data equal to. Without data equal to, this is the nothing but the table, the same table that we have seen. Okay. Number of CDM groups without the data. Okay. This is the same. That is the header of the number of CDM groups without data. Okay. So once you put 2, automatically this. These 2 things will be unoccupied, but these other 2 things can be put, data can be put. Okay. When you put is equal to 3, that means all the other things are also, when you have 3 CDM groups, automatically all the other things will be covered with by blue. Okay. 2 ports with without data equal to 2, because it may be multi-user MIMO. Okay. 2 ports without data equal to 3. This is for single user 2 ports, but it may be multi-user MIMO with 6 users. So you will have this as blue, means there's no data there. Okay. 3 ports. I mean, so many nice examples are there. I would suggest you to go through this. I mean, okay. So they generated lots of examples. I'll share this on our classroom. I would suggest you to go through this also, so that things become a little bit cleaner. Okay. If you have any questions, you can we can then discuss in the next class. Fine. So with this, we'll stop this class today. In the next class, I'm going to start CSIRS. Okay. See, before CSIRS, what I want you to do, all of you to do is read the 38.211 spec and read the textbook once and look at the shared notes. Okay. It shouldn't take too much time. I mean, and on Saturday, I'll answer whatever remaining questions are there, and then we'll start the CSIRS and SRS, which are used for TAD and non-TAD configurations for measuring channels. Okay. Any other things, or we can close down for today?
So one question is not related to the present class, sir.
Okay.
Sir, this is clear, sir. Now this reference signal, it is not continuous transmissions. Means in every consecutive symbols it is not available. But here, if you take LTE, sir, if you recollect my few set of last questions, I have grouped, I have submitted to you. Last time LTE, there is a reference signal, so we can measure the EMF. We can take the EMF radiations because there is a continuous power in that reference signal.
Yes.
So that time you said once DMRS it will be cleared like that. We thought so. But now,
so essentially, see, in DMRS, you always symbol 2 or something will have DMRS for every user.
Yes, sir.
Okay. So, but the only problem is, see, suppose you take 100 megahertz bandwidth, Vijay. You take 100 megahertz bandwidth. Okay. If the base station is serving only one user, the user may not be allocated all the 100 megahertz. He may be allocated only some 2 megahertz or 3 megahertz. So your DMRS will be present only in the 3 megahertz. Okay. But that DMRS will be of constant power. DMRS, I mean, other than the power scaling beta factor that is there, it will always be constant for power and it will not fluctuate. It's always QPSK symbols. Okay. In general, what will happen is the multiple users will be there. Most of the times, the entire spectrum will be occupied. I mean, there's no dearth of users. And most of the times, the second symbol will always have DMRS. Okay. So we can use the second symbol to measure what do you say, the transmit power by the base station. Because pilot symbols, you cannot do power control on the pilot symbols. Sorry, DMRS you can do now. DMRS you can do, by the way, DMRS you can do, but downlink there's no power control anyway. Sorry, there is no power control on the downlink. Yeah.
You mean it is power reduction will not be there, complete power will be transmitted.
Yeah, so if you look at the DMRS, I'll show you one thing. There's something called this beta factor. I have always been neglecting this beta factor. Okay. Beta will be explained somewhere. This. Okay. So, okay. Here. The UV shall assume sequence is scaled by a factor beta DMRS to conform with the transmission power specified in 38.214. Okay. So this beta, let's open 214. I will pull this out. They tell you how to do the beta one, reference signal procedures. Let me just look at that beta. Somewhere some beta is there. I will read this beta. So the beta cannot take too many values. It can take only fewer values. Okay. And this beta is generally, so if we know what this beta is, then you can use that to measure your EMF. It is like it's like the CSI reference signals in LTE. So, there's nothing like across the entire band, you'll never have completely. But most probably, if there are enough number of users in a system, then what will happen is all the users will be allocated across the entire bandwidth, and most probably symbol 2 will always have DMRs.
Yes.
You have to do some jugaad. It's not so clean like LTE, where there's some reference signals always in second symbol completely. That you cannot assume every time in 5G and R. But what you can assume is if there are enough users, the users will occupy the entire bandwidth, and all the users will have to have DMRS that's present in symbol 2. Yeah. Any other question? Okay, then we'll switch off today, and we will meet again on Saturday, and we'll start the next